All right, ladies and gentlemen. So, for the second assignment, there will be no worksheet, no sheet you have to fill out in Google Docs. I'm actually going to have you do the study island for this. I just want to give you a quick rundown on square roots and then what I'm going to be looking for, what you're going to be expected. Now, very quickly on square root, I think a lot of you know what numbers are perfect squares. So you kind of think about the square root of 4 is 2. That's a perfect square. The square root of 9 is 3. That's a perfect square. The square root of 16 is 4. Square root of 25, 5, and so on. These are all perfect squares, right? What makes these numbers perfect squares? I wanted to give you a nice visual on what this means. So think about it. Let's think about it in terms of actual squares. Let me see if I can bring something up here. All right, so let's think about it in terms of actual squares. So if I say the square root of 4, so 1, 2, 3, 4. We said the square root of 4 is 2, right? Think about it in terms of a square. 4 tiles, they make a perfect square, and so the area we can think of as 4. What would oops, wrong color here. What would the length and the width be? The length would be 2, the width would be 2. So the square root of 4, think of the square root as the area, or I'm sorry, the number as the area, and then the square root of that number is the length and the width. Let's do one more. Let's do it with 9. Let's take 9 tiles, put them together, and there you go. The area is 9, the length and the width is 3. The square root of 9 is 3. So we can make a perfect square with this amount of tiles. All right, so now these are perfect squares. What about like the square root of 5? You can put that in your calculator. It's going to come out to be 2 point something, probably like 2.1. And let's look at, well, can we make a perfect square with 5? No. What about 6? It's a rectangle, but it's not a square. 7, 8, 9. It's not until 9 that we have another perfect square. So you can actually use squares and think, okay, 4 is a perfect square. We have 4 tiles, we can take the square root of that. 5, we can't, not a perfect square. 6, that's a rectangle. 7, 8, not until we get to 9 do we have another square. 10, can't. 11, no perfect square, not a perfect square. 12, not a perfect square. Not 13, not 14, not 15. It's not until you get to the number 16 where you can do the square root of 16 is 4. So if you hadn't seen that, I just wanted to show you that real quickly and give you an idea of what we're going to be taking a look at. So perfect squares, we know that we can take the square root of those. Now, square root of 5 or square root of 6, square root of 8, these are things we can put in our calculator, but that's not what we want to do. Because if you put the square root of like square root of 8, you're going to get a decimal that's never going to end. And when we deal with numbers, we want to be as precise as we can. And so we don't want that decimal. So we need to think about how are we going to simplify this kind of thing as small as we can, but not have a decimal. So that's what we're going to do here. Okay, so square root of 18, is it a perfect square? We know the square root of 16 is 4, right? Square root of 25 is 5, so we can't take the square root of 18 nicely. If we put in our calculator, it's probably going to be, well, it's definitely going to be in between. So think about it this way. Square root of 16 gives us 4. Square root of 25 gives us 5. So square root of 18 is in between here, right? So that means that it's going to be 4 point something. It's going to be 4 point something if we were to put into our calculator. But again, that's not what we want to do. So how are we going to break this down? Here's what I want you do, and this is what you're going to do on the study island. You're going to need a piece of paper to do this, and on the third assignment, you are going to have to do this again. So here we go. What we can do is we can break this down into factors, as in the square root of, and just think of two numbers that multiplied 18. You could do the square root of 2 times the square root of 9. 2 times 9 is 18. This is allowed. We can break it down. If we want to put it back together, we would just multiply what's underneath the square root. So I'm just breaking it down into factors. Now, this is not the only way you could do it. I'll show you the other way in a second. All right. Now, 2 is prime. Prime just means you can't break it down any further. The only factors of 2 are 2 and 1, but we can break down the 9. Into 3 times 3. So now everything is broken down as far as you can. 3 is also a prime number. So what you want to do is you want to break it down into prime numbers. And let's circle everything that's prime, everything at the end of our factoring. A lot of people call this a factor tree. It does look like a Christmas tree starting at the top and kind of branching down. And let's list it out. Square root of 2 times square root of 3 times square root of 3. So now this, what we have here that I'm about to circle, this equals the square root of 18. 2 times 3 is 6. 6 times 3 is 18. Now, this is not all we wanted to do. What we want to look at now is, do we have any pairs? And we do. When you have a pair, it comes out of the square root. And I'll show you why here in a second. Anything that does not have a pair stays in the square root. This is the answer. 3 square root of 2. Our goal with this, if we can't get a perfect square, is to break it down as far as you can. Now, the reason that we look for pairs is this. Think about it this way. What's the square root of 9? Square root of 9 is the number 3. That's where that 3 is coming from. But rather than stopping at the 9, I think it's just easier to look for pairs. All right, let's do another one. Well, let me do this first, actually. One thing I did want to show you here is this. So many of you might have been thinking, well, 2 and 9 isn't the only way you could do it. You could do 3 and 6. 3 times 6 is 18. But break down 6. You got 2, you got 3. 2 times 3 is 6. And look, you end up in the same spot. As long as you're breaking it down as far as you can, you end up with the same exact thing. Here's your pair, becomes a number, and always put the number out in front of the whatever's left underneath the square root. Think about it this way. This is something I think I said last year to some of my kids. The square root is a prison. All right. And if you're going to break out of prison, you don't want to just do it by yourself. You want a buddy. All right. So these 3s are in prison, but they have each other. They have a buddy. They break out. They're outside of the square root. The 2 is still stuck inside. Doesn't have a buddy. All right. All right. Let's do, I think, one more. 1 second. All right. We got 2 more. So 72. All right, 72. Let's just pick 2 numbers that multiply to 72. 9 and 8. 9 times 8 is going to be 72. All right. 9 can be broken down into 3 times 3. That's as far as you can go there. The 8 can be broken down into 2 and 4. 4 can be broken down into 2 and 2. You're going to end up with a lot of 2s and 3s when you do these problems. All right. So circle everything that led us to a dead end. Every prime number. All right, let's list them out. Square root of 3, square root of 3, square root of 2, square root of 2, square. Alright, you're looking for buddies. Get them out of the prison. 3 is a buddy, 2 is a buddy. That lonely 2 at the end does not. Alright, so then this becomes 3. This becomes 2. And then square root of 2 stays. Now you're not completely done. 3 times 2, these are numbers. They multiply 6. Square root of 2. There's your answer. Square root of 2 stays underneath the square root. 3, there was a pair of them. They had a buddy. 2 times 2, 2 gave us buddies. 3 times 2 in the end gave us 6 square root of 2. Alright, one more. I've done that every single time. Alright. 144. Let's think about it. Square root of 12. 12 times 12 is 144. Now, some of you are already looking at this and looking at me, or thinking, why am I doing this? I just want to show you something. So many of you know that 144 is a perfect square. 12 times 12 gives you 144. So the square root is 12. What I want to show you is this process works whether it's a perfect square or not. So this is nice. So if you don't recognize the perfect squares, especially as you get to bigger numbers, you might not. But what you notice is circle all of your primes. Alright, list them out. Square root of 3. I'm going to put the square root of 3 next to it. And you have 4 2's. So those of you who saw it right away, square root of 144 is 12. So just to make sure that everybody knows that you can do this process no matter whether it's a perfect square or not. They all had pairs, so 3, not inside the square root, times 2, times 2, that does give you 12. So whether it's a perfect square or not, you can do this process. So find factors, break it down into the prime numbers, break it down as far as you can, and then look for pairs, simplify from there.